Okay, welcome. Good morning. I'm Ellen Honigstock, the Director of Education here at Urban Green Council. Welcome to the fourth event in our Energy Upgrades in Historic Buildings series. Urban Green's values are excellence, inclusion, collaboration, and engagement. We invite you to be mindful of these during the program, both while you're viewing the presentation and also while asking questions. So for this event, we are focusing on a 10-unit cooperative apartment building in the Upper West Side that has electrified its heating system. And as you probably know, it's a rare opportunity to speak with stakeholders of such a retrofit project. And before I introduce the speakers, I'd like to thank Con Ed for their sponsorship of this event. So today we'll hear from Tom Sahajian, who originated the project and managed the project, Umit Sirt, a senior engineer and partner at Tatum Engineering, Lisa Harrison, a resident of the co-op and a board member of the co-op, and John Hacker, the director of decarbonization and energy efficiency development from Daikin. So first, I'm gonna hand this off to Tom and then to Umit, who will both give us some details about the project.
Hi, I was muted. Sorry, folks. So I'm Tom Sahajian. I originated the project and managed it, and I'm still managing it. We're still getting information from the project. This is a project we learned a huge amount on, and we're continuing to learn a huge amount on. And as we learn more, we'll be sharing what we learn with the general public because we think this is a topic of great interest. Here we go. So the main things that we learn, and this is by no means an exhaustive list, is that the biggest challenge on projects like this is to minimize refrigerant leaks. And the reason for that is that the refrigerant that's used in these systems has a very high global warming potential, 2,200 times that of CO2. So if the system is not set up properly and carefully, and the refrigerant leaks out, then you might get a lot of savings of energy, but then the greenhouse gas savings that you were hoping for just literally evaporate into thin air. So it's very important to make sure that the installation is done properly. We also think that in order to reach the city's goal of 80 by 50, which is reducing greenhouse gases 80% by 2050, the systems have to be metered either by a direct electric meter in an apartment or a sub-meter, because without getting feedback, the users they don't have an incentive to reduce their usage as much as possible while still remaining comfortable. Another key item is that a lot of buildings thinking about changing their systems have the idea that they want to also get rid of the old heating system. And personally, I think that that's a mistake, because I think that what's going to happen in the future, as more and more buildings convert to heat pumps, Con Ed's peak demand period is going to shift from the summertime to the wintertime. And just like they do now, they will pay users to reduce their peak demand on the coldest days, so that they don't have to increase the size of their system. So I like the idea of using the existing heating system from time to time on the coldest days of the year as a demand limiter. Another issue that a lot of folks are concerned about is that they're going to have to spend big money to upgrade the electrical system in the building. And in this project, we did not have to do that. And the service to each apartment was actually quite low. It was only 40 amps times 2. And that's roughly the lowest I've seen in most apartments in New York. So if your building has more than that, then you almost certainly will not have to do an electrical upgrade, which is a huge money saver. We felt that air sealing certain parts of the building to reduce drafts, to reduce stack effect, and to improve tenant comfort was an integral part of the project, not just an add-on or an option. And because of the price difference between gas and oil, we're often told that, well, buildings that have gas can't do this because they won't the economics won't work out. But in fact, because of changing prices, practically on a daily basis, many times gas and oil-based buildings will have similar economics. And so that's something to definitely keep in mind. I'm hitting the down arrow. Oh, there we go. Some of the other key things that we learned in the process of going through this project and other projects that I've been involved with is that there's already a shortage of properly trained heat pump techs. And this is not just in New York, this is nationwide. In the course of doing this job, we concluded that in most cases, you really should have somebody knowledgeable overseeing the job just to make sure everybody's crossing their T's and dotting their I's, because it's very easy to make shortcuts that end up compromising the quality of the installation. We encountered a lot of weird things in this particular building, and I can guarantee you that every building has some quirks that no one knows about and will not be discovered until you actually start doing the installation. So you just have to be prepared for that. We also had an experience with draining the condensate from the indoor units. I'll talk about that a little later, but one solution to that problem is to drill holes in the wall to let the condensate drip outside. And that turns out to be not as great a solution as draining it on the inside. I'll talk about that in a minute. And domestic hot water was not part of this project because the necessary equipment is not yet available in the United States, but that is changing. And we're actually hoping at some point in the near future to also change out the domestic hot water system into a heat pump type system. So very quickly, the original system that is still in the building because it's still providing domestic hot water was a cast iron sectional steam boiler. It's about 40 years old. It's in very good condition. It could continue to operate for many, many years to come. And this on the right-hand slide here, you see the domestic hot water part of the system. This is a very typical New York City boiler that provided both steam and hot water to the building in one package. So the new system consisted of outdoor units, which are these rectangular things here. And we installed them in 3 different locations. Let me just go back a second. We installed 4 of them on the roof. And then we installed, I don't know what, we installed another 4 of them down in the back of the building, about 8 feet above the ground. And then we installed 2 next to the fire escapes. And we did this because we wanted to minimize the length of the refrigerant runs, and also because we wanted to show that you don't have to put all of these outdoor units on the roof. And there are many reasons why you wouldn't want to do that. It takes up a lot of space. If you have to replace the roof in the future, it makes it more difficult. And especially as the building gets taller, it makes the refrigerant runs longer and longer to the point where you get to past the recommended length as specified by the manufacturer. So we found 3 different locations, and so far they've all worked really well. The indoor units are the things that you most likely see if you've been to, well, I don't know, practically anywhere these days. A lot of places have been installing heat pumps, and the indoor units, you see that sometimes they aren't as attractive as one might like, but these units are actually quite attractive. The 2 main options are mounting on the wall, which is the most common type that you see, and then a floor mounted type, which kind of looks very similar to a floor mounted fan coil unit, which a lot of people are already used to seeing. And it's important to remember that these particular heat pumps are cold climate heat pumps. There is no backup resistance electric heat elements. And we had spectacular success with this over the last 2 winters. No one got cold. No one, the temperature in the apartments didn't plummet when it got cold outside. They worked really, really well. And so that's a worry that a lot of people have, and they shouldn't have that worry. As long as it's rated for cold climates, it should work out very well. As I mentioned earlier, we did not upgrade the electrical system. However, what we did do is we increased the breaker capacity because the wires that were there allowed us to do that. And so we just gave ourselves a little bit more headroom. And I'm very happy to report that in the almost 2 years that the system has been installed, we have not popped a single breaker that I'm aware of, and have not had any complaints about that. So that was a big success. Now, the results of this project have really been quite amazing, and Umit's going to talk about this at greater length, but basically the project itself, when you take all the costs into account, and I won't delineate them now in detail, but taking everything into account, we ended up saving a huge amount of energy, a huge amount of greenhouse gases, and we even saved a little bit of money, even though electricity is much more expensive than fuel oil. And if we go to the next slide, I did a scenario where we looked at different, more likely situations than the ones that we've found ourselves in. And as you can see in this column that says new cost savings, depending on what happens, if oil prices increase, if the grid becomes more green, which by law it's supposed to, and or if this building had been a lot more wasteful with its heat than it was, and Umit will talk about that, you can see that the new cost savings in each case gets considerably better. So this project really was very, very successful, far beyond what we really expected. And I think it's time for Umit. Yeah.
Hi, everyone. This is Umit Sirt, a senior engineer and partner in Tatum Engineering. We are located in upstate New York. I'm in the climate zone 6, whereas this project is in climate zone 4. And many of our projects in Tatum Engineering, consulting or design, we almost electrified all of our design in the last 2 years. So for us to work on this project was very attractive. We had a very thoughtful management, and I know Tom for 20 years, very thoughtful manufacturing and ourselves. It was a very good process, and we learned a lot. We had foresee some of these learned, but there are some unexpected also items we learned. Next. This building is 10 units with 9,690 square feet building. It's a co-op, and I believe it's 1-bedroom and 2-bedroom apartments. So here we have the steam distribution system and a window air conditioner as a pre-retrofit before the implementation. Next. We have a combination of floor-mounted and wall-mounted installs, indoor units, and this is one of them. This is how a floor-mounted indoor unit will look like. Next. In our M&V, measuring and verification, we had applied 2 different approach, and this is to basically cross-check with each other. It was one of them was whole building analysis. It's basically using the field bills and the collected data via e-gauge and using the actual heating degree days for the period for pre and post install. And the other option was calibrated simulation, where the collected data from the e-gauge, the apartment surveys, a blower door test, and build an equus energy model to mimic the building for a pre-retrofit situation, and use the same model with the changes in the building during that 2 hours, and apply actual and typical weather data. We had installed 4 different e-gauges. 3 of them was for the individual heat pumps, and 1 of them for the whole building. Next. So, this has been quite a talk about what is the annual overall heating COP for a heat pump. And what we gathered in our whole building analysis is about 3.38. It's between 335 and 3.4, basically. And our calibrated simulation model, it ended up being 329, 3.3. I will say that calibrated simulation is more granular, more details. So if it's engineers in New York City, if you were to do a high-level calculation for your building, I will suggest using 3.3 or 3.4 in between. And that, of course, you will need to multiply your energy use with the thermal efficiency and distribution losses, and then whatever the building heat load is, divided by 3.3 will give you with electric conversion will give you the likelihood of the electric conversion consumption. Next. So we also look to the energy cost. Like Tom mentioned, when we had started the project, the oil price was 2.48, and now $4, more than that. The energy cost savings were, with the whole building analysis, was about $1,600, where we don't have the space cooling here. Next. And with the calibrated simulation, it's about $1,200 for the whole building. But again, this is the old oil price. The prices fluctuate almost daily. You never know if there will be another pandemic or another war. But at the end, if we think about the oil price was about $4, you could easily assume the energy costs were almost like 80% higher than what you're seeing here. Next, please. The biggest result for us was the greenhouse gas emission. The reduction with the whole building analysis and calibrated simulation was very close to each other. It's about 49, 48, 49, 50%. This is for the whole building. If you were to look for only HVAC and domestic hot water, that reduction is about 58, 59%. But for the whole building, we ended up, we are halving with this change on the HVAC only, installing heat pumps is reducing the greenhouse gas emission for a typical New York City multifamily building about 50%. Next, please. So we have a better temperature controls. Talking about thermal comfort, we have a better temperature controls in individual rooms in the apartments. Earlier in the process, tenants were concerned about their bathrooms will be cold, and there will be cold air coming from the hallways and basement. So, according to the surveys we had, there is no complaints about the cold bathrooms or the common area hallways walls. But we had received cold floor complaint in the first floor apartments. And this is basically the boiler that was being used for heating in the winter is not being used for heating anymore. It's being used for the domestic hot water, and the operation of the domestic hot water is very likely much less. And then, we saw opportunities with air sealing and roof insulation. air sealing happened during the MNV, and I think it did help. So we did a blower door test pre and post. I believe ACH, air change per hour, was from 0.68 to 0.66. But the building was, air sealed. It wasn't a leaky building, basically. There was, we installed the roof, the building installed the roof insulation after the MNV period. So, again, this is not really, these are not for energy savings, but more for the thermal comfort. Next, please. So throughout this process, Tom and I, we have been talking and making suggestions to the building management. So I think the four main ones were examine the potential issues in the first floor because of the cold floor complaint. One of the among 10 apartments, one of them had this set and forget approach. And that one had the highest electricity consumption. So it should be investigated further if the set and forget approach is really the cause of higher electricity use, and the other apartments not having complaint, it will question this approach. Implement the building envelope improvements, roof insulation and air sealing, and building management took care of that. And then the domestic hot water, this is a sort of the magnitude of the results was a surprise to me, that the domestic hot water was provided with immersion coils in the boiler, and the boiler is still there, and it's just working for now for domestic hot water. So typically what we do is we get the summer use for domestic hot water, and that becomes our baseline. And then that baseline is for throughout the year. And then the rest of it, we think that it's the space heating. But here in the winter season, the domestic hot water use increased about 60–70%, just because of running this large for space heating boiler for this purpose. So the building management now is thinking, we are suggesting them to replace that as well with a heat pump domestic hot water system. Next, please. So again, 48% greenhouse gas emission reduction with the adverse effect of this domestic hot water heating situation. If that effect wasn't considered, or if that wasn't affecting negatively, the greenhouse gas emission was going to be almost 57%. We calculated almost 60%. We, according to our analysis, this annual heating COP is around 3.3, 3.4 for New York City. In here in Ithaca, what we see is 2.7, 2.8, and that is climate number 6. Average temperature of New York City is about 42, 43 Fahrenheit in heating season. Here it's about 35, 36 Fahrenheit. So I think it's reasonable, is my conclusion. And again, the set and forget approach should be investigated more. And we learned that immersion coils operate very poor in winter. And the losses because of the jacket losses, cycling losses of the boiler increase the use dramatically. Next, please. Tom mentioned about it, but it is really difficult to predict the energy cost savings, there are so many different factors. It can be project, specific, or it can be just the political situation of the time. In this building, there was no demand charge. So that, the no demand charge in apartment rate structure was an advantage. In a master metered building, the situation can be different. Or any building that has a demand charge, it could be a different very different situation. This building was particularly very efficient when we started the project. I worked in New York City for 10 years, and hundreds of buildings. I recall look into the database of steam, one pipe, two pipe steam heated buildings had about 14 to 18 BTU per heating degree days per square foot. This building had 10.3. And so what that meant was the building management was already very efficient with the HVAC system. So the potential of energy savings was already low in the building. So basically, any building that has overheating, large overheating, and opening the windows, tenants opening the windows, wasn't the case in this building. So it's fair to say that there will have been larger energy and cost savings for an average New York City steam heated multifamily building. Next, please. Okay, that's about it. Thank you.
Okay, thank you very much. That was very interesting. We are getting a lot of questions from the audience, and keep them coming. I'd like to remind you that you can vote up questions, and generally that gives us some sense of which questions are of most interest to the audience. But before we go to the questions, I want to introduce our other two speakers and just get the conversation started. So Lisa, can you tell us a little bit about yourself and your role in the project, a little bit about the building and how they felt about being an experiment?
Okay, sure. Well, we're a 10-unit self-managed HDFC co-op. And the way this started is some people in our building wanted to replace our 40-year-old boiler and convert to gas, as some of our neighbors had recently done. So putting aside the question of whether there was actually a need to replace the boiler, I just really didn't want to lock us into another 40 years of burning fossil fuel. No one should be getting a new boiler at this point. So I started investigating other options, and air source heat pumps seemed like the most promising. And I was looking into incentives for energy efficiency upgrades. There were none for heat pumps at that point, though there are now. But one of the agencies I contacted was called Retrofit Accelerator, where I was talking to a woman named Valerie Corbett. And one day Valerie called me and said, I know these two energy geeks, Tom Sahajian and Ian Shapiro, who want to do a research project in New York City on replacing an old steam heat system with air source heat pumps. And they're looking for a building to be the test case. Would you be interested? So of course I was, and contacted Tom and Ian, and that's how we got connected to this project. And I have been working very closely with Tom for the whole time. In every area I have learned a lot, I have to say. And how did the building feel about being an experiment? Well, it was very mixed at first. There was definitely some trepidation about it, and it took a long time for us to come to an agreement. But I could share some of the obstacles and enticements if you'd like to hear that. Let's see. When we to point out also that when we finally did agree to go forward with this, people were kind of into the whole idea and kind of liked the idea of being the first. It was kind of exciting in a way. But anyway, at first, there was a lot of hesitation about it. One certainly was cost. Two, fear of change, because the boiler has worked for us for 40 years and we should stick with that. That was definitely an attitude some people had. Also, people had heard that heat pumps don't work in cold weather. This was true of the early heat pumps, but as Tom and Umid have said, now they have cold weather heat pumps, which is what we have, and they work, I think, down to minus 13 degrees. So we've had no problem in the winter with them at all. People also wanted to see another building where this had been done before and get to talk to them and see how it worked out, which is very reasonable, but I could not find one, anywhere. I don't know if any other building has done it, which speaks to the need for this project. So, those are some of the reservations people had. Some of the things they really liked about the idea of getting heat pumps were having control over your temperature in your own living space, which we have not had in New York. Normally, if you're hot, you open the window. If you're cold, you put on your space heater, and that's what we used to do. But with the heat pumps, we have different indoor units in different rooms. You can have them set to different temperatures. You can have some on, some off, and each one comes with its own remote where you can control the options, as you like, according to your particular preference and comforts. So that people like a lot. They're quiet. There's no banging steam pipes or hissing radiator valves or noisy air conditioners. And they do heating and cooling, so we don't need the window air conditioners anymore, which people were really happy to get rid of because they were always noisy and big and heavy, and they blocked the light and they could fall off the windows. So everyone loved getting rid of those, and the heat pumps are great during the summer.
Oh, that's great. Thank you. Thank you so much. And now I have a question for John. That once the team knew what they wanted, considering there haven't been projects like this before, how did you help them select the right equipment?
Thanks, Ellen, and good morning, everybody. So in terms of the equipment, we worked with the project team, including the residents, Tom and Ian, to evaluate the kind of three major form factors that Daikin offers heat pumps in. That includes VRF, or which Daikin refers to as VRV, mini splits, and our multi-split systems. Initially, Daikin had thought we'd use the VRV, which is a central heat pump system. The building would have likely needed to install 2 VRV systems, which provide heating and cooling to many apartments, and they would have been powered by the common electric account for the building. But then the co-op would have had to bill back the residents for their usage based on our software, which ultimately Lisa and the rest of the residents weren't very keen on. So, that kind of eliminated that as an option. We also evaluated mini splits, which are smaller decentralized heat pumps, which basically connect one indoor unit to one outdoor unit. These would have worked fine, but did create a challenge in siting and installing about 30 outdoor units in the building. That was a bit excessive, probably would have added some cost. So ultimately the building decided to use a multi-split heat pump, which connects one outdoor heat pump unit to many indoor units. So using that equipment form factor, each apartment has their own dedicated heat pump system that resides on their Con Edison electric account. It allows them to provide heating and cooling to 3 or 4 indoor heads, and ultimately just have to pay Con Edison for their electric usage. The equipment used for this building is our Aurora multi-split heat pump systems, and they're kind of optimized for the climate in New York and the Northeast, where they provide 100% of its heating capacity down to 5F. As Lisa has suggested, she was spot on. They operate in heating mode down to -13 degrees Fahrenheit, highly efficient in heating and cooling, and they're listed as a NEEP cold climate air source heat pump, which made them eligible for rebates through Con Edison's Clean Heat program.
Thank you very much. Okay, very quick. Which of you, who wants to define COP?
Oh,
Tom, go for it.
Coefficient of performance, it means how much energy you get out versus how much energy you get in. And the way heat pumps work is that they take a small amount of energy and they move a large amount of energy from one place to another. So they either move heat from inside your house to the outdoors in the summer, or they may move heat from outdoors to inside your apartment in the winter. And they're much more efficient than burning fuel to create heat.
Right, so COP, a better COP is a more efficient, a higher COP is a more efficient unit.
Higher number is better, yeah.
Okay, Tom, while you have the mic, what does set and forget mean and why is that an issue?
It's a tough one to summarize. Basically, most people are familiar with having what's called a night setback thermostat in their apartment or in their house, and you reduce the temperature in the space overnight to save energy. There is a belief in heat pump world that for various technical reasons that that's not a good idea with heat pumps. But what we have found during this project, because we've been instrumenting the heck out of this building and taking lots and lots of data, we're beginning to find that maybe the set and forget is not necessarily the best way to go, and that some kind of setback regime actually would be more efficient. And that's one of the things we're continuing to look at as we extend the project into the future.
Thank you. So a question from Alistair Bramley. So how much construction was needed for the installation and what was the aesthetic impact of the units? Was plastic guttering used to run, I guess, to conceal the cables, and were they placed in the wall or roof cavities? And what was the impact on the owners during all of this? Did they have to leave the apartments?
Yeah, well, we did all leave our apartments during the installation, and it was quite a mess while they were installing. They did clean up fairly well afterwards, but you still have to clean everything when you got back. Let's see, most of the lines are in the ceiling, but then some apartments, they were not able to do that because their ceilings were high. So they ran them along the walls, and mostly people have soffits built, which we did after putting them in. And I'll show you, this is mine. This one has a little soffit right there. Do you see it? That's just a small one. Some of them are bigger.
I love the show and tell. That's awesome. Thank you. Thanks, Lisa. We did not plan that in advance.
Okay. Can you just let me, I have to go answer the door. So
yes. Turn off your camera. Thank you. So Mike Garazzi, sorry if I mispronounced your name. What voltage do these heat pumps use, and did this factor into not having to upgrade the electric?
The voltage is 208. Did it factor into not having to upgrade? I guess maybe technically it did. Because if you have 208 volts, then the current is lower. I'd have to think about that, but they operate on 208 volts.
Can I add a little bit to that, Ellen?
Yes, please. Yes.
Yeah. So Tom's absolutely right. I would suggest, I think pretty much every heat pump system that comes in this form factor operates on that same voltage. So it's very typical. I think there's a couple of things baked into the electrical characteristics here. I think one is there's, just a misconception that frankly, we can't power heat pumps with the electric infrastructure that we have today. Tom, I don't know if you said it today, but I've heard you say it in the past. I think this was one of the worst case scenarios in terms of what might exist in buildings. And we've proved that it can handle the heat pump well. The other thing I might add is different styles of heat pumps have different kind of amperage ratings for the circuits that they require. The equipment used here is comparatively to some others a bit lower, so that could have been helpful as well. So it's really important to look at those amperage ratings for the systems and try to choose a system that efficiently uses the electricity that it's provided and needs.
Thank you. A question from Bill McCracken. This is a very small co-op. It's 10 units. And it seems like that may have given you, well, actually the question is, did it give you advantages or disadvantages compared to larger co-op buildings doing a similar project? Do you have any thoughts on that?
Originally, I had hoped, oh, sorry, Umit, go ahead.
In terms of energy use, I don't think it will give any major advantages or disadvantages.
So in terms of the outcome, but in terms of the process or in terms of the construction?
Well, the construction and the process can be different, but in terms of just energy use, I don't think it will give any advantages.
Okay, Tom, did you want to add to that?
Yeah, originally, when we were planning this project, we had actually hoped to have a building that was about 20 units because we wanted something that was as big as possible so that when we presented our results, people would realize that even if the building was a certain size, the lessons that we learned would be applicable to buildings of as many sizes as possible. But when we found this building and it was perfect in so many other ways, we decided to go with it, even though it was 10 units. And I'll be very honest with you, I'm so glad we only went with a 10-unit building because all the work involved in doing a research project is just very time consuming. And if I had to do all that work for twice as many apartments, yeah, I probably wouldn't have made it to today. But in terms of construction and the thrust of the person's question, I would say it's not a big deal.
Okay. How long did the process take?
You mean the installation process?
Yeah. How long did the installation process take?
Started in early June of 2020, and we finished, I don't know, August.
So this summer.
Yeah, it should have gone a lot more quickly, but we ran into some kind of wacky problems. And it wasn't like they were there every single day during that period, but
Right, that was also COVID time as well. A question from Jennifer Arrutia. Their co-op is looking to switch out the boiler system for their 36-unit co-op. So what do you recommend as a starting point, and what advice do you have for them?
they're planning to switch out their boiler.
Yeah.
Yeah, I would say, please don't do that. I have an article that I wrote for Habitat Magazine on this very topic a couple of years ago. And if you give me the person's email address, I'll send them a copy of it. And that gives a pretty detailed answer. But the basic answer is, I don't think anybody should put a new boiler in their building unless the thing is just so unbelievably decrepit that it isn't possible to repair in any meaningful fashion. But there are very few boilers that meet that standard as far as I'm concerned.
Okay, thank you. You mentioned a lot about monitors. Did you install monitoring meters in each apartment to measure over time, and what education did you do for the tenants?
Tenant education was mostly how to operate the units. The monitoring, we monitored this building up the wazoo. We had a meter on each individual heat pump so that we know exactly how many kWh was used by each heat pump. We also monitored each apartment, and we monitored the entire building. We also had 80 or 90 temperature sensors throughout the building, like 6 in each apartment, some in the hallways, several in the basement, etc. So we have an unbelievable amount of data.
Okay. You may have mentioned this. Does the domestic hot water system still use gas or oil? And was that energy use included in the savings?
Yes.
Yeah, it still uses oil. And yes, one of the things that we discovered, somewhat to our surprise, although it made sense when we thought about it, was that the domestic hot water system in the wintertime became less efficient. And so the amount, if we assume that they use the same amount of hot water, which that we were not able to measure, then that efficiency went down, and we included that in all of our savings calculations. It was a very, very elaborate savings calculation that took absolutely everything into account.
That's great. So here's a question from VJ Thomas. You mentioned that metering and sub-metering is essential for 80 by 50. Can you expand on that point?
Yeah, I mean, NYSERDA has research going back many years showing that people use much less electricity when they're metered. And we know, in fact, I was speaking to John about this the other day. And I happen to know that in the housing authority, because all their buildings are master metered, there's a ratio. Well, I check that. Some of their buildings are master metered, but some are direct metered. And the worst ones in the portfolio are something like 7 times the electric use of the ones that are direct metered. So the goal of 80 by 50 is to reduce greenhouse gases 80% by 2050. And the idea that that could be achieved without a feedback mechanism to people so that they get price signals about what they're doing, I don't believe it's possible.
Okay. So there's 2 related questions, one from Caitlin M and one from Gigi about mini splits versus centralized systems. Excuse me, Gigi says that they, I think mini splits are ubiquitous in Southern Europe and in some cases have created terrible aesthetics so that cities are becoming stricter on where they can be located and how you see that in New York City. And the related question is if it would have been more efficient to have installed a centralized system. Does it depend on the number of apartments in the building? What led to that decision?
It would not have been more efficient to install a centralized system because the fan losses would have been huge. It also would have been much more expensive and disruptive and possibly even less efficient. I'm not 100% sure about that. The aesthetics, yeah, I understand that that's going to be an issue. And that's why we tried to find multiple locations for the outdoor units. The aesthetic problems have not completely been solved. But you know, I don't want to say the aesthetic problem of half of New York City being underwater. I think that's a bigger aesthetic problem, but that's just me.
Can I add a little to that, Ellen?
Yes, please.
Thanks. Yeah, so when I hear the aesthetics, I think the question is really about the exterior of the building. You know, we're very used to and accustomed seeing bulky window ACs sticking out of windows, frankly, dripping water on people that walk by. That's an occurrence that all, I think, New York City residents are familiar with. And I think the question is really related to the mounting of an outdoor heat pump to a location of the building that's visible from the street. And frankly, that's not something that I've seen as acceptable to a North American audience yet, certainly not in New York City. So the location of the outdoor heat pump equipment was all done in a way that it's not visible from the street. So, you know, I don't think that this has altered the aesthetics of the building at all in any way. The outdoor units are on the roof, they're on the back of the building or on the rear sides, right? So from that perspective, I don't think that this approach will impact the aesthetics. The interior, there's another aesthetic question there. We're now introducing kind of indoor heat pump units on the wall. Some people are, you know, their natural reaction is not kind to them. My experience having a few in my home, you become accustomed to them very quickly and they just begin to blend into the space, right? So, you know, if you go to other places in the world, Asia or Europe, you see this equipment in the front of buildings mounted on balconies, and it's just part of their life. It's different. I don't think we're ready to do that in New York City yet. And I think we'll find ways to work around that if we never become ready to.
Thank you. Yeah, Umi, go ahead.
Well, one thing to add that is that you will be also eliminating the window air conditioning, which is also an aesthetical problem in New York City. When you go to the apartments, all those have, and it's a little bit of security, you know, any of those window air conditioners can fall down. And it does also feed higher infiltration into the apartments if they leave the air conditioner in the windows and they, you know, the people does it. And I totally agree with Tom about the centralized system is much more energy user by far, actually.
Okay. right, I'm going to switch a little bit. There's 2 or 3 questions about the building envelope. What was involved in air sealing the building? What was the R value of the existing building? Can you speak to that for a minute or so?
I think what Tom had done is air sealing the dumbwaiter shaft. And that was the biggest improvement we had done. And then, the roof insulation wasn't there. And then I think, I don't exactly know how much we added. It wasn't, it was after the MNV period. So it's better Tom talks about that.
I don't know, 8, 9, 10 inches, something like that.
Okay.
And that's not strictly air sealing, but, and we only did it about 3 or 4 months ago.
Okay, I think you cut off. You did what, 3 or 4 months ago?
We added the roof insulation, I think in January of
Got
this
it.
year.
The roof,
Right.
I can tell you how much insulation, because the installer said that it was, they put in 16 inches of insulation. Also, my video is turned off, so I can't turn it on.
Oh, okay. Very can turn that back on. There you are. There's a bunch of questions about financing, all different specific questions, but maybe you could just tell us how the project was financed.
Maybe I could take a crack at that. I saw a couple of questions about cost rebates, so I'll try to bake everything into one answer. At a high level, I think to get the heat pumps installed in the building, it was close to $17,000 per unit, so per apartment unit. I do want to preface this with, I'm just going to use big round numbers to make this kind of easy, but generally on the right order of magnitude. And at the time, Con Edison was offering rebates of $7,000 per apartment unit. So kind of net cost would have been close to $9,000 or $10,000 per apartment. We had, but before deciding to move forward with the air source heat pumps, the building did evaluate an upgrade to a natural gas boiler. I think that cost was roughly around $8,000 per apartment unit. So, I think if you think about the incremental cost for an extra roughly $2,000 per apartment, I think Elisa covered a lot of the advantages and benefits that the heat pumps provide. And it seems like a pretty reasonable cost to bear. One other thing in terms of cost that I don't think we've touched on yet is not applicable to this building, but we're going to be operating buildings under the guise of local law 97 pretty soon. And we haven't talked about it, but this project would have major implications to any potential fines or elimination of fines in the future under that scheme, right? So I think this building isn't subject to that regulation, but buildings that are would potentially see an enormous cost reduction or elimination of fines under local law 97, which I think is impactful.
Thank you. Lisa, a question for you. How long were the tenants out of their apartments, and did they all have to leave at the same time?
No, we did not all leave at the same time. They did like apartment by apartment. And I think people were just out of their apartments for a few days, like maybe 2 or 3 days.
Okay. Thank you. Question for John. How do the refrigerant types and leakage risks and amounts vary by system? I don't know if that's too much of a question.
I could try to tackle that a little bit. Most cold climate air source heat pumps that are available today are split systems, meaning there's an outdoor piece of equipment, they're connected to indoor pieces of equipment, and that's done through field install refrigerant piping. Today, as Tom mentioned, the default refrigerant used in these systems is R410A. Roughly has a global warming potential of 2100 or 2200. we've gone through various iterations and generations of refrigerant. Today, we as a manufacturer and frankly the HVAC industry are planning to move to more environmentally friendly refrigerants that will likely include refrigerants that are lower than 750 global warming potential. So Daikin is the only manufacturer that we're aware of that's offering equipment today in North America that uses low global warming potential refrigerant, which is R32. So Daikin sells Atmosphera. It's a mini split. It's a cold climate mini split, and it's available in just a handful of states right now because of the actions that those states have taken to update their building codes. But we're seeing a lot of activity in that space, and I would expect that equipment using that more environmentally friendly refrigerant will be available soon in other states as well.
Thank you. All right, I have two more questions. The first one, Tom, quick one for you. You mentioned putting the condensate lines inside versus outside. Can you just elaborate on that a little bit?
Well, the options are using the existing steam risers as your condensate lines, and or if drilling through the floor is not a big deal, which in many buildings it's not, putting in an interior line that would go down to the basement and then go into the drain.
Okay, thank you. And then, so the last question, moderator's prerogative. What advice would you give other co-ops considering electrifying their systems?
To talk with an energy consultant as soon as possible. And because there are so many different factors around the building that the engineer really need to look at and consider. The daily changing of the oil prices and all the requirements of New York City coming. These are all different factors, along with the incentives, connect incentives exist or not. So they may need someone that can lead on this process.
They have to have a good installer, and that's easier said than done because when you're just starting out, you don't really know how to even find out or judge that. But it is really super important. We're going to actually try to write up some things for people to look for and maybe to ask about before starting.
Oh, that's great. And I put the contact information for the accelerator into the chat. We're going to put it on a slide, but we forgot to do that. I forgot to do that. All right. Thank you so much for all this information. It's really great to hear from people who work so closely together to do a project like this. We need so many more of them. So we're going to close out. I want to show you some of the events we have coming up. And first, I want to thank our sponsor, Con Ed, for sponsoring today's event. We are very appreciative of it. And we have several big events coming up, most notably our conference on June 15th. We're calling it Electrification to Electrification, talking about the remaining barriers, many of which we talked about today, and many of the questions were left, and I'm sorry we couldn't get to them all. And we also have coming up the last event in our energy upgrades in historic buildings is Hotel Marcel, a concrete brutalist building in New Haven. It's a fascinating project. With our Emerging Professionals Committee, there's a tour of the Cooper Recycling Plant. It's a favorite of everybody all the time. And our summer member reception at Cook Fox on June 30th. We hope to see you there. Thank you again for attending. And this information will be up on the Urban Green website on the event page within a few days.